Hi everyone, so this video is continuing on with our liquids and solutions unit, and I'll be talking about solubility rules. So I'm going to prep you with some definitions, and then we're going to get into how to use your table F and table G in your reference tables. So what is this solution? And before I get into this, just so you know, for note-taking wise, you should definitely write down the words I have in red or underlined, and then any examples or visuals that I give you might be a good idea to write down as well for your own notes. So what is a solution? A solution is a homogeneous mixture of substances in the same physical state. So this can be atoms, ions, or molecules, and then when they are added to a second substance, they are uniform throughout. So they are a nice liquid solution. For example, when we add table salt to water, we do get this uniform solution in the water. So we first add the solid and then we get a nice liquid solution because those salt molecules dissolve into our water, which I'll get into a little bit more in detail in a few slides. Types of solutions that we can have. So we can have a solid solution where a solid is dissolved into another solid, and that is called an alloy. This is when metals are mixed. So brass, as you may know, is not an element on our reference table because it is a mixture of both zinc and copper. Another type of solution we can have are a gas solution. And an example of this is air. That's a mixture of many different amounts of different gases. And then the one we're really going to focus on in this unit is our solids or liquids being dissolved into another liquid to form a liquid solution. So we're going to be looking at particularly liquid solutions. And then some vocab words that you should be familiar with already are solute, which is the substance that is being dissolved, and it's typically the substance we have a smaller amount of. And then the solvent is a substance that is doing the dissolving, and it's typically what we have a greater amount of. Our most common solvent that we use is water, and when we use water as a solvent, we have aqueous solutions. And we know from doing reactions that in our solutions, when it is an aqueous solution, we write a little AQ notation next to our compound to signify that it is in water. Okay, so solubility. This definition of solubility is very important. So it is how much of a solute would dissolve in a certain amount of solvent, and the key part of this definition is at a given or certain temperature. So this is temperature dependent, and we'll get into some factors that affect solubility, and temperature is going to be one of them. So we say that when materials have high solubility, they're considered to be soluble. When materials have low solubility, they're considered to be insoluble. So keep this in mind as I'm going through the factors and examples. Think about when you make coffee. Certain parts of the coffee grinds and grounds dissolve, however, some parts of the materials do not. Think about when you add sugar or cream to your coffee. The sugar and cream dissolve into our coffee that we just made. However, the spoon you're using to stir the sugar or cream does not dissolve. Okay, so some factors that affect our solubility. The first one being the nature of the solute and the solvent. So that's probably a familiar phrase you've heard before is like dissolves like. You may have heard this in biology. So what this means is we have to go back to our bonding unit where we identified compounds as being polar or nonpolar or ionic. So remember we had covalent compounds that were polar or nonpolar, and then we have our ionic compounds. And if you don't remember this stuff, I suggest going back to your notes from that unit and refreshing your memory on those. So this nature of both the solute and the solvent determines if we're going to have a soluble or insoluble solution. So when we have a nonpolar solute and a nonpolar solvent, we will get a soluble solution. When we have a nonpolar solute and a polar solvent, our solution would be insoluble and we would see solid crystals or compounds around in our solution. It wouldn't be a nice uniform liquid solution. If we have a polar solute and a nonpolar solvent, then what's going to happen is we're going to have insoluble compounds, or solutions, because they don't have similar properties. If we have a polar solute and a polar solvent, because these have similar properties, like dissolves like, we will see that uniform soluble solution. We have to remember that ionic compounds act very similar to polar compounds. So they're going to have similar properties. So they're going to fall under a like dissolves like category. So if we have an ionic solute and a nonpolar solvent, those will be insoluble because they do not have similar properties. If we have an ionic solute and a polar solvent, because those have similar properties, we will see a soluble solution, which brings me to the example of salt in water that I talked about earlier. Salt is ionic and water is a polar compound. And so what happens when salt dissolves in water, the sodium becomes a positive ion and the chlorine breaks off to a negative ion. And then because we know water is polar, we know it has slightly positive and slightly negative sides. So the hydrogens become slightly positive and our oxygen becomes slightly negative due to having more of the electron density, and that comes from oxygen being more electronegative. So with that being said, opposite charges attract. So our chlorine, our negative ion, is going to attach itself to the positive side of our water, the hydrogens, and our sodium ion, that is positive, is going to attach itself to the negative oxygens on our water, making that fully dissolve into a nice uniform solution. Our second type of factor that affects our solubility is temperature. As temperature increases, most solids become more soluble in water as well as liquids. Gases act in an opposite manner. As temperature increases, the solubility of gases in liquids decreases. And I will show you this in our table G graph in a later slide. Pressure is another factor of solubility. It has little to no effect on the solubility of solids and liquids. However, it has a large effect on gases. As pressure increases, the solubility of gases in liquid increases. So think about when we have a can of soda and we open it. The pressure is decreasing when we open that can of soda. That's that little sound you hear. The CO2 is no longer soluble at the lowered pressure and it escapes as bubbles, leaving you with flat soda. So that's why, especially in the summer, our soda becomes flat quicker because of both this temperature factor and the pressure factor. So table F is a table that has guidelines for us for some ionic compounds and whether or not we will have a soluble or insoluble product. So this tells us with that insoluble and soluble product, if it's insoluble, we're going to form a precipitate, which is a word you should write down. A precipitate is a solid that forms in a reaction, and when we have a precipitate form, that is when we are going to know that we had a reaction happen. When we don't have a precipitate form and we only have two liquids form, it is difficult to tell if a reaction did or did not happen by just looking at it. So that helps determine and helps us identify if a reaction is or is not happening. So how to read this table? This left side are compounds that are typically soluble. And then this right side are compounds that are typically insoluble. So we see then there's some exceptions to both sides. So group 1 ions, ammonium, nitrates, acetates, hydrogen carbonates, and chlorates are all always soluble no matter what they're combined with. Our halides and sulfates have some exceptions. So when halides or halogens in group 17 are combined with silver, lead, or mercury, they form precipitates because they're actually going to be insoluble. So what this is saying is these compounds are soluble except when combined with whatever is next to them. So when halides are combined with anything else but silver, lead, and mercury, they're soluble. When they're combined with those three, they're going to be insoluble. Same goes for sulfates. When it's combined with silver, calcium, strontium, barium, or lead, it's going to be insoluble. Everything else, it is soluble compounds. Same goes for over here, same way we're reading this. So carbonates, chromates, phosphates, sulfides, and hydroxides are typically insoluble except when combined with the following that are listed next to them. So that's how you read table F. So some examples to follow. Silver nitrate and sodium carbonate solutions are mixed together. Will a precipitate form? If so, what is the name of the precipitate? So when we're looking at these, we have two ionic compounds adding together. So this is a double replacement reaction. If we don't remember these, go back to our reactions unit. So we can write this out in word form. You don't need to use the formulas. So silver nitrate and sodium chromate add together, and our double replacement reaction, we get A and D, so we get silver chromate. And then we get C and B, so we get sodium nitrate. Then we need to go to table F to figure out if we're going to get a precipitate or not. So we look up nitrates, and in table F, nitrates are always soluble. Then we look up chromates, and chromates are typically insoluble except when combined with group 1, calcium, magnesium, or ammonium. It is combined with silver, in this case, so it's actually going to be still insoluble, making silver chromate our precipitate that forms in the solution. Second example, according to table F, which ions combine with chloride ions to form an insoluble compound? So if we look at table F and our chloride, we're going to go to our halides. So table F, our halides, chlorine. Chlorine is typically soluble except when combined with silver, lead, and mercury. So let's go to our example. We want an insoluble compound. So if we're looking at our chlorides, we want to find an answer that has either silver, lead, or mercury in it. And that's going to be answer C is silver because our chloride ions, again, are listed as soluble except when combined with silver, lead, or mercury. Then the last example, which ion combines with barium to form a compound that is most soluble? So we want soluble answers now. So we're going to go to barium. Oh, I'm sorry. This one's a little tricky. We are not going to go to barium. Barium's not one of the ones listed on our table F. We have to look for each of these individual ones. So if you go to table F, you're going to notice that our hydroxide group are listed as insoluble except when combined with group 1, calcium, barium, strontium, or ammonium. All of the other examples that we have in this problem are always insoluble. So we look at our sulfide group. Those are insoluble except when combined with group 1 or ammonium, and barium is neither of those. Our carbonate group is insoluble except when with group 1 or ammonium, which is not barium. And then our other answer was sulfates, which are over here, which are soluble except when combined with silver, calcium, strontium, barium, and lead. So since we have barium, this would be an insoluble solution. So the only one that gives us a soluble solution would be our hydroxides, because they are insoluble except when combined with barium. Okay, so that would give us answer B there.